Okay.
Good morning, thank you for joining us. My name is Grace Schiebel, I'm the project manager for HHBS Engineering, and we are here today to give our progress presentation on the Brooks subdivision development. So first off, I'd like to introduce the team. We have Andrew Hernandez, who is our transportation engineer, and we have Jabril Hoskins, who is our environmental engineer. I am the structural lead for the project. A little bit about the project. It's located in Valparaiso, Indiana, just north of Valparaiso High School. The land is being developed for residential use, specifically a subdivision, and the project will include the design of a 2-story visitor center, the design of roadways, pedestrian access, and a parking lot, as well as the design of a collection system, lift station, and bank stabilization system. So moving into the structural portion of the project, I was responsible for designing a 2-story structure. It should be approximately 40,000 square feet with a 1,200 square foot covered outdoor attached space. It will be located on the northeast corner of the project. This is due to the already developed subdivision located to the east of the project site. This will allow both that subdivision and the developing subdivision to have access and use to the building. So more about the structure itself. It will be 2 stories as mentioned before. It will be 130 feet by 150 feet, composed of structural steel. This comes out to be about 40,500 square feet. It will have a 30 foot by 30 foot covered outdoor attached space, which is also composed of structural steel. So starting off with the loads, before you build, you have to figure out what loads act on the structure. So specifically looking at the wind loads and the snow loads, as well as the dead and live loads. The wind loads were calculated using the ASCE figures listed in the table, as well as the value pulled from ASCE hazard tool. Using the equation found on the screen, I was able to calculate the wind loads to be 27 pounds per square feet. The snow load was calculated using the same theory. I pulled values from ASCE 7-16 with various tables from that section, as well as a value pulled from the ASCE hazard tool. The snow load was calculated to be about 46 pounds per square feet. The live load was pulled from ASCE as well, and the dead load self-weight is pulled from the steel manual. So this is a structural member layout for the building itself. It is very similar to what has been presented before. The only change is that the outdoor attached space is no longer a 40 foot by 30 foot, it's a 30 foot by 30 foot. The first floor and the roof are symmetrical in design, and this is important moving on when looking at how the beams and the girders are going to be designed. So this is a profile view of the building, giving a more in-depth look at what the columns look like and what the brace frames are going to be for the structure for the lateral load. It was determined to be an X bracing for the lateral load, and the columns will be 15 feet tall for the first floor and 10 feet tall for the second. The first picture on the top is of the north and south side of the building, and the bottom is of the east and west. So this is a memory summary table. With the loads and the dimensions being finalized, I was able to go ahead and calculate some forces on the members, as well as figuring out with the steel member approximately what type of members should be used for the building. The first floor has listed the columns, beams, and girders just because of the symmetrical design of the building. The beams and girders used for the first floor will also be able to be applied for the second floor. So future work, I have to finalize my RISA floor design as well as my RISA 3D. I have to do the column design and any additional structural item, as well as finalize my cost estimate. At this time, I'd like to turn it over to transportation.
Good morning. I would like to begin by reviewing my scope. I've been tasked with the design of 2 new roadways, Bell Park Road and Old Oak Drive, as well as the intersection connecting the 2 roadways. Also, I'm responsible for pedestrian access alongside Bell Park Road. And finally, the client has requested for the design of a parking lot for the proposed visitor center on site. To properly design each transportation component of this project, several design guidelines were used, many being from INDOT, in order to properly design each transportation element of this project, and now I will show you each of those that I have designed. Starting out with the typical sections, on the top we have Bell Park Road, and the bottom we have Old Oak Drive. Starting with Bell Park Road, it features 10-foot wide pedestrian paths on either side of the roadway, as well as 4-foot shoulders at a 4% grade, and 3 12-foot wide travel lanes at a 2% grade. As far as subgrade depths, it contains 5 inches of number 53 aggregate, followed by 3 inches of base asphalt, followed by your 2 inches of surface asphalt. As far as Old Oak Drive, it is a local road, and it has 2-foot shoulders at a 6% grade and 11-foot travel lanes at a 2% grade. As far as the subgrades, we have 3 inches of number 53 aggregate, followed by 3 inches of base asphalt, followed by 1.5 inches of surface asphalt. The pedestrian paths and the parking lot are expected to have the same subgrade depths as Old Oak Drive. This project contains one intersection. It is a stop-controlled intersection with Old Oak Drive stopping for Vale Park Road. And much of the design went into the right-hand turn lane for Old Oak Drive. Starting out, I chose a value of 75 feet for the storage depth of the turn lane, and that was found using the peak hour traffic volume provided by the client. As for the taper length, I chose 110 feet. The reason being, NDOT requires the taper length to be 100 feet or more. Old Oak Drive has travel lanes of 11 feet, so that would make the taper length 10-to-1, which is a nice, easy ratio for myself and the contractor to work with. Finally, this intersection features turning radii at 50 feet. This was selected because it accommodates the single unit design vehicle for this project. Next, we'll look at our alignments, starting with Vale Park Road. The top is the horizontal alignment. This shows an end-to-end view of the roadway. The main points of this alignment are the 454-foot radii. These radii will allow for smooth travel for drivers as well as sufficient sight distance. On the bottom, that shows the vertical profile of Vale Park Road. The red line shows the new profile for when the roadway will be completed. The maximum grade of this will be 6%, and the minimum will be 0.74%, which falls within the design criteria range of 0.5 to 10%. For the sag and crest K values, they are 49 and 29 respectively. So the sag and crest K values will allow for smooth travel along the vertical curves of this project, and the grades will allow for the water to properly drain towards the west side of the site. So Old Oak Drive, it's much the same story here. The horizontal profile is shown on the top. This horizontal profile features 300-foot radii. Again, that will allow for sufficient sight distance for drivers, and the vertical profile is shown on the bottom. The maximum grade for this profile is 5.79%, and the minimum is 0.65%. Again, that falls within its range of 0.5 to 11%. And the K values for these sag and crest curves are 37 and 19 respectively. And finally, we have the parking lot. This parking lot features 167 parking spaces, 10 of them being ADA accommodated, and each parking space is 10 by 20 in area. This parking lot features garbage access as well as pedestrian crossways for safe pedestrian travel. Much work has been done. However, there is much work to be completed. I need to calculate my inlet spacing for my curb and gutter system, as well as select appropriate culverts for when our roadway crosses over a river or a stream, as well as refine my construction cost estimate that is in progress right now. And finally, I need to hash out any construction details for when the construction process begins. Now I will turn it over to our environmental engineer.
Hello everyone, my name is Jabril Hoskins and I am the environmental engineer on this project. To quickly recap what my scope is, I am responsible for designing a collection system that includes manholes, a lift station with a forest main, and then a bank stabilization system. All the tasks of this project must be in compliance with the city of Valparaiso, Porter County, Indiana, as well as the federal government. Note that throughout this presentation, I am referring to a bank stabilization system that is the vegetated rock gappings that was selected at the end of the preliminary design phase. This slide here details some of my design criteria. So for the collection system, the pipes must maintain a minimum slope of 1%. The flow velocity must range between 2 to 10 feet per second. And then the manhole spacing must be at a maximum of 400 feet. The minimum pipe slope is from the construction standards of Valparaiso. The flow velocity being 2 to 10 feet per second. The 2 feet per second minimum, that is to allow for these pipes to go through a self-cleaning process and then at a maximum of 10 feet. That is to prevent any damage to the lift station. And then also the maximum of 400 feet for the manhole spacing. That is per the Indiana State Department of Health. The lift station must be large enough to house 2 pumps, prevent sewer overflow, and minimize any sort of odors. And then for the bank stabilization system, that will be based off of the site topography, the length of Beatty Creek, as well as have a maximum design life of 20+ years per the USDA. This slide here shows you all the collection system and the plan view. As you can see, the parking lot and building structure have been added to that. As indicated by the yellow arrows, that is the flow direction, the right circles are the manholes, and then the orange rectangle at the bottom of the screen indicates where the lift station will be located at. Exiting the lift station will be a force main that conveys the wastewater to a higher elevation. On the slide here, you all can see that from the lift station, we would be going approximately 500 feet to Hampstead Court. That is where the wastewater will be discharged at, and to the next collection system in that neighborhood. The assumption that I'm making here is that the collection system in that neighborhood is able to sustain the flow from the first subdivision. On this slide here, we have a profile view. This comes from Vale Park Road. As indicated by the yellow line, that is the road alignment. The green line is the ground elevation, and then the pipe material that I've selected is SDR 26 PVC. Why, you may ask? That is because that complies with ASTM 3034. This pipe material has thick pipe walls, so that prevents any sort of damage to those pipes. And then the manhole's depth must be a minimum of 8 feet, and then have a diameter of 4 feet. That complies with AASHTO M199. As shown in the picture, that pipe slope is 1%, and that is maintained throughout. And then there are manholes at each of the inlet and outlet ends of the pipes. So currently, the system peak flow rate is estimated to be at 520 gallons per minute, and the total dynamic head is 45 feet. So because of that, using the pump curve shown in the middle of the screen, I've selected a Farmisa 40S pump. This pump has a maximum flow rate of 960 gallons per minute, and then a maximum head of 90 feet. For the future, I will continue through the design process of the lift station, as well as the force main and bank stabilization system, and then perform cost analysis. Thank you, and now I'll give it back to Grace to close our presentation.
At this time, I'd like to open it up for any questions you may have. Yes.
Can we go to the last drawing, Jibril, where you show the profile? This one. So why do you have 2 manholes so close to each other?
Okay, so the honest answer to that is because I was Civil 3D and designed it as, because when I made the drawings, it was based off of the road line that was already segmented into it. And so that's just what the drawing I had set up as, is that actually going to be what it is in practice.
You do understand that Civil 3D is just a tool. You make the decisions.
I didn't do it. I should have done
So, and you actually presented your criteria about that distance between the something. Even if there is, let's say you are starting from right to left in this case, you can shift the locations to make them more appropriately located, or at least divide that distance if you wish.
Since the next slide, if you could, since we're close to the slide. So that's going to operate at an efficiency of 52.5% or something.
So that does concern me, right? I actually changed this pump from what was in the report, and I did that because I wanted a higher flow rate, like a higher maximum flow rate. That is to account for additional connections to the collection system. That is part of what it's being designed for. I looked it up, smaller pumps tend to have a smaller efficiency rating, and so having 2 pumps for redundancy reasons, that'll kick in if one pump goes to failure, the other one will work. But that pump is subject to change.
Andrew? Show the slide with the parking lot. What is that cross-hatched area next to the building?
That is I guess where the people will be entering the building, so I wanted to put like a painted area for drivers to,
Okay,
be aware of that many pedestrians will be in this area.
sure, okay. And then, the intersection plan view, that one. As you're, I think you need to figure out what to do with that middle lane on the west side. You know, it looks like they're just running into the people who are turning left, coming from the east.
The west side of Vale Park Road.
The west side of Old Oak Drive, as you're approaching Old Oak Drive on Vale Park Road from the west, that middle lane is undefined. You need to figure out what to do.
Yeah, again, we're still in the design process, but that's a median lane for people to turn. Again, I don't know what exactly what will be within this site. So I left that for left turn lanes, left-hand turns for whatever might be used. So that won't be like a lane for drivers to drive through, but that is more of a
All I'm
turn.
saying is you need to figure out what marking to use currently,
Yes.
so that people aren't in that
Yes.
left turn lane when they approach this intersection, because there are people probably in the other lane, so
I understand.
just figure out what kind of lane marking you need to do there.
I understand.
Since when you, Andrew, I'm not a transportation person, so can you educate me how you come to the decision between the different lane width between the Old Oak Park or Old Oak Drive and the Vale Park Road?
Yeah, it just,
So you use like 12 feet for the Vale Park and 11 feet, and then actual. Well, I'm thinking as maybe like, let's say if I am the owner and I want to minimize land use, like the right of way. So why you want to put like, for example, the passengers lanes to be like 10 feet, lane width to be 12 feet, and then the additional. So you're taking lots of my land, in other words, in there, compared to like Old Oak Drive is only like 11 plus 11, no shoulders in there. So just educate me on the process, the decision making.
it really just comes down to the NDOT standards. So I use the NDOT design manual that was so 12-foot lanes are the standard for a collector road, which is Vale Park Road. Old Oak Drive is a local road. So 11-foot lanes are the standard lanes.
How about the 10 feet? If you go back to almost the first,
Oh, the pedestrian path, is that what?
yeah,
That
over
was,
this one, yep, still
yeah,
here.
that
So
was
you
just,
have 10, 5,
mhm.
and then you go like almost like another 22 feet. Lots of space, lots of land being consumed.
Yeah, so the 10 feet was, that was asked by the client, to have 10 feet for the pedestrian paths. Those are the pedestrian paths.
And what's a 5 feet?
That's the grass buffer. That's just that's a standard. That's what you typically see. So that's why I chose 5 feet for that. And then, yeah, you have your road, your curb and gutter, and then you have your roadway.
So what's your total right of way in this case? Yeah, I'm trying to add up numbers. 37, like 70 something.
Correct.
That's lots of land.
Do you know what the right-of-way is on existing Vale Park? That you're connecting to? Is it, I mean, it is kind of wide there, isn't it?
Yeah, I mean, I was given a site, and I was given, what was the client asked for certain specifications, and I followed those specifications.
Who's your client?
Valparaiso.
The city of Valparaiso.
The city of Valparaiso, as well as the Brook subdivision.
Alright. hopefully they understand that you're taking all of that land for a road.
Well, they asked in the scope for a pedestrian pathway as well.
Okay.
So they want us to connect the Vale Park Road.
Okay, Grace, here's a question for you. Something attracted my eyes, a beam called B2 with a depth of 27 and a weight of like 235 somewhere in here. It is.
Yeah. Okay.
So that's a huge.
Oh yeah, it is very huge. This is for my hand calculations. I took the loads. This is definitely not what they're going to be. I ran the model with RISA Floor already, and I'm figuring out, because I'm at the stage where I'm putting it in RISA Floor, and I'm transitioning to RISA 3D, because RISA 3D really looks at the lateral loading and the stability of the building. And what it's projecting is way less than this, but this is just, I backhand calculated by hand the approximate, so this is a way over estimate of what the building needs, so I probably will not use something that's like this huge.
So which do you think more accurate, your hand calculation or RISA calculation?
RISA.
You don't trust yourself?
Well, it's more precise in like how it's, because the method I used is I did the load calculations, so it's going by hand and doing the tributary area and then calculating it that way, and then I did general assumptions on like some of the beams have a larger attributed area and will be a lot larger than what they actually need, and what Reese is going to tell you, because Reese is more accurate on like being more precise. This is just a general preliminary design that I can go ahead, because the main goal for this was to get a preliminary design, because then I can take all this information and input it into RISA to get a better idea of what the building's going to look like. And then definitely after I finish the RISA model, I'm going to go back through and I'm going to recalculate a lot of stuff just to make sure that what I'm calculating by hand and what RISA is telling me, it matches up instead of the numbers that are here on the screen.
Can you point out on the plan view what beam is that? Because I know the Spanish staircase, it's large, but I want to see what type of loading is on that beam. Where is it located to be exactly?
B2 is going to be sitting, it's going to be, is it next to you? B2 is next to you. So yeah, it's going to be one of these beams over here, or one of the ones outside. It's going to be the one that's because these are spanning 25 feet across, and this one's 35 feet, which is why it's a lot bigger, because of that. It's no longer 25 feet, so the tributary area is not 25 feet across, it's 35. So it's carrying a larger area, as well as it being an exterior member.
Which one makes it carry less load being exterior in this case?
It's got a tributary span width of 30 feet instead of 25, and then the area is a lot larger. So then when you do the calculations to figure out what load is actually being carried, it's going to be a lot heavier, as well as it being a first floor, I believe.
Are you sure it's a, I'm sorry to interrupt, are you sure it's an exterior beam or exterior girder? But exterior girder should have less tributary area. I like your answer that you said that this is a preliminary design, of course, but it might be one of the interior beams.
Yeah, it's definitely something I'm going to have to go back and double check, but these numbers where I have hand drawings of the actual building that look like this and have all the labeling of what each are that are listed in the report, but it definitely could just be an error on the Excel, and it's definitely not something that is it's just a base of what I'm starting on, and I will definitely moving forward be double checking all these numbers after I finish the reset calculation. So it's not a set in stone number, this is just preliminary. These are kind of what the numbers are. They're way over exaggeration, and moving forward they will be finalized and most likely be changed.
I have a question for you. So if you, actually we are on that slide. Is there any particular reason that you decided to use brace frames in both perpendicular directions? Because common practice is just to use moment frame on one side, on one direction, and brace frame.
So the building itself will be brace frames and gravity frames. The brace frames aren't specifically, like their placement's not like exactly where it's going to be at. I'm still doing the calculations to figure out where the brace frames will be located, and it's going to be based off of where the building is unstable. So these are definitely subject to changes. It's just a preliminary design, and it will be, in the final presentation, it will be different.
No, my question is not about the location of the brace frames. We have two perpendicular directions, like west, east, and north, south, for example, or X and Y. You have used in braced frame in both directions. Common practice is to use rigid frames or moment frames in one direction and braced frame in the perpendicular direction.
In the preliminary design, it was determined to just be used bracing frame and gravity frame, and not use moment frame in the design, but it's definitely something that will be looked at further.
Yeah, I just wanted to know if there's technical reason or just probably your client is short of money. So, yeah, okay.
Any other questions?